Alright, continuity on an open interval. Find the x values, if any, at which f is not continuous. Which of the discontinuities are removable? Graph each of these. So graphing is going to be the hardest part of all of these. Graphing is going to be very crucial, again, to this class. So let's graph this first function, and then we'll talk about the continuity. So here's my function. Y equals cosine of pi x over 2. So typically the period of the cosine function is equal to 2 pi. Okay, and we're going to say that that's equal to t. Okay, so there's a formula when we have a number other than 1 in front of the x, or the independent variable here. It's called a phase shift. And hopefully you learned this when you took trigonometry, but the period is equal to, for this one, 2 pi over b, where b is the number in front of x. Okay? So, the period for this function, we're going to do 2 pi over b, which is pi over 2. And then if we want to simplify this, we can multiply the numerator and the denominator by 2 over pi and end up getting 4. Okay, so now what this does, when this cosine, when this pi over 2 multiplied by x, what that does is changes the period. Alright, so the period here is going to be 4. So let's take a look at the graph. Typically the period of the cosine function is 2 pi if you had y equals cosine of just x. But we don't have that. So the period, instead of being 2 pi, it's going to be 4. So if this is 4, and this is divided into fourths, so this is going to be 1, 2, 3. And then the general shape of the cosine function is going to be the same. It's just the period is changed. Now it repeats itself every 4 units instead of 2 pi units. Okay, so looking at this graph, is it continuous? Yes. So we would just write continuous. Okay, and then since there's no discontinuities, we don't have to talk about whether it's removable or non-removable. Let's look at B. Okay, so we've graphed this function before. Before we graph it, let's look at the domain. So x can be any number as long as x is not 5. Because when x would be 5, that would make the denominator undefined. So there's my domain, which means there is going this is not going to be continuous. There's going to be some break in the graph. So let's graph it by using a table. Alright, so let's pick numbers in this interval first. So let's try 4. I'm going to plug 4 into this function. The numerator would end up being positive 1. The denominator would be negative 1. So overall this would be negative 1. If I pick 3, the numerator would end up being positive 2. The denominator would end up being negative 2. So again, negative 1. So I think you can see here as we continue to pick numbers smaller and smaller in this interval, it's going to end up being negative 1. Let's see what happens when we pick numbers in this interval. So let's pick 6, plug 6 in, you're going to get positive 1, and the denominator you're going to get positive 1, so you're going to get a 1. So basically every single number that you pick in that interval is going to end up being positive 1. So now let's draw the graph. So let's see, let's start with 4, negative 1, 3, negative 1, 2, negative 1. It's going to continue to go this way. And then 6, 1, 7, 1, 8, 1. It's going to continue to go that way. So now the question is, what happens up here when these points are going to get closer and closer to 5? So it's still going to be 1 until it gets to 5, then it would be an open circle, would be undefined. Same thing down here, as these points get closer and closer to 5, it's still going to be negative 1. Until you get right to 5, then it would be undefined. So you can see here, this graph is obviously discontinuous, and it is a non-removable discontinuity at x equals 5. So there's B. Let's look at C. Here we have a piecewise function. So to graph the piecewise function, I'm going to graph each part of the piecewise function separately on the same graph, and then look at the graph overall. So I'm going to start with 2, and I'm going to write closed, because at that point 2, it is a closed point because it's less than or equal to 2. So when I plug 2 into this function, I get negative 4. Then the next point I'm going to pick, I have to pick a point that's less than or equal to 2. I've already done 2. The next point that would be less would be 1. Plug 1 in, I get negative 2. Since this is a linear function, 2 points is fine. Let's look at the next piece of the piecewise function. The next piece of the piecewise function, this would be a quadratic function, so I'm going to need more than just 2 points. Again, I'm going to start with 2. This time I'm going to write open. The reason why I'm going to write open is 2 does not exist, it's greater than 2. When I plug 2 into this function, I'm going to get 4 minus, this would be 8, so negative 4. Negative 4 plus 1 would be negative 3. Next, I'm going to try 3. When I plug 3 into this function, this would be 9 minus 12, which is negative 3. Negative 3 plus 1 would be negative 2. Next, I'm going to try 4. 4 squared would be 16. 16 minus this would be 16 would be 0, so now you're going to have 1. Next, I'm going to try 5. 5 squared would be 25. Minus 4 times 5 is 20, so this would be 25 minus 20, which would be 5, plus 1, this would be 6. So let's take a look and see what we have now. Okay, so first of all, let's graph this part of the piecewise function. It's a linear one, so we got a 2, negative 4, and I've got a 1, negative 2. So the graph is going to continue this way. Okay. Then let's graph this part of the piecewise function, which is a quadratic, so it should be a parabola, or at least piece of a parabola. So I got a point at 2, negative 3, and that's open circle. I got another point at 3, negative 2, close 4, 1, and 5, 6. So it's going to look like this. Okay. Now if I'm looking at the graph again, this would be a non-removable discontinuity at x equals 2. There's definitely a break here. It's more than just removing one point.